Hello everyone, welcome back to my math channel online today again. Follow up with my introduction to logarithmic function from my MS PowerPoint presentation. Today I would like to get into the lesson about logarithms, and we will try to understand what is the number of logarithmic means and what is the characteristic of the logarithmic function based on their restriction, domain restriction. So on the board, I have something written on the board. So let's read together. So the topic today, I state, understand logarithmic function. And that is our objective today. So the first question, the first part of the section, I would like to show you how to use a calculator and evaluate the log number. So let's say I have log 40 equal 1.60206. So let me show you from my calculator here. We will, if you see the logarithmic button on your calculator, LOG, of any calculator, doesn't have to be graphic calculator. So in this calculator, or even though on your cell phone, you see the function LOG. So then you hit that. So it opened the log function for you and you key in 40. Close the bracket, hit enter. So that's the number I recorded on the bar. It equals 1.60205 and I round up become 1.60206. So let's key in the next one, log again, and 0.75, enter it. So it equals minus 0.12494. Now let me key in the next one, log of minus 5, and let me enter it for you. So if we key in log minus 5, we got the error message. And therefore on the border, I wrote undefined. UND stands for undefined. Let's key in the next one, which is log 0, and enter it. Again, we got the error message on my calculator, and therefore it's undefined again. So now we know that. So what does that tell us? It tells us that why the reason of minus 5, we get the error message. It shows us that not just minus 5, it could be any negative number. So you're not allowed to find the value, evaluate the value of log of negative number. So we know that it will reject any negative number. And log of 0, so it means if you have a log, let's say log of x, then we know that we have to state the restriction, x have to be bigger than 0, which is x have to be not negative number and not equal 0 as well. So based on this, we know we have a restriction like this. Also, I asked you the question, what do all of these numbers above mean? So how do we understand about these numbers? What do these numbers mean to us? So I will answer for you. The answer is, it means usually when they write the log, usually we have log of the base 5, base 2, just like the exponential function, we have a base, so log have a base as well. And for the base 10, they don't write it. It's just like the square root, right? We have a root 2 on the top of radical size, but usually we omit it. We don't write the root 2, except root 3, then we have to write root 3 or root 4. So like any other base, we have to write. So it's like here you have a log of base 3 of number 27. And so that means that when it say log like this, we understood this is the base 10. So log of base 10 of 40 will be equal to this number. So it means that if we use the base 10 and we power the number of 1.60206, let's see what the number you will get. So I'm going to key in 10, base 10 to the power 1.60206. I'm going to enter. What's the number you see on my calculator? The number 40. So log of 40 equal 1.60206. It means 10 to the power 1.60206 equal 40. So that's what it means. And therefore, I can explain all of these numbers as well. It means that if we put the number 10 as the base to the power minus 0.12494, we know our answer equal this number, 0.75. And so on, except this one doesn't work. So that is the meaning of the logarithmic number I just explained to you. Now, let's go to my second bar. So based on this understanding, we're going to progress to number 2. Rewrite each logarithmic in exponent form. So the logarithmic form have a log, and then the base here is number 3 of the number 27. Equal 3. So this is another way of writing instead of like this, because we can put in here log of base 10 of 40 as well, similar like this. But for the base 10, we tend to omit it. But for base 3, we have to write. So if you see any log number, say log of base 3 of 27 equal 3, the way we convert it to, and I put the arrow forward and backward, it means they, okay, so let me put the arrow this way. And I'm going to put here as the arrow go back like the inverse, right? Inverse of the exponent function. So we're going to go forward for the exponent. So we're going to convert into exponent form. And convert to exponent form, you use the base 3. So you write 3 to the power 3. This is the power 3. 3 to the power 3 equal 27. And that's how you convert into the exponent form. Now, let's do the next one. Next one is base 3 as well. So we're going to write base 3 to the power 5. Remember, the evaluation of log is the power of the exponent. So 3 to the power 5 equal this number, 243. That's how you convert from log to the exponent form. So the next one, similar, you look at the base 3, so you write base 3 And you look at the power here, which is the evaluation of the log, which is number 2 on top. And actually, this should be minus 2. So 3 to the minus 2 will be equal 1 over 9. And that's how you convert it. Okay, so the next one, similar, will be 3 and this actually 3 to power of 0 will be equal 1. If they don't give us the power here, but we know the power should be 0 because any base, the power 0 will be equal 1. For this question, they don't give us, so we have to predict. And what do you predict? So the power for this is you can write square root of 6, or you also can convert to 6 of the power 1/2. So it means 6 to the power 1/2 will be equal square root of 6. Remember this. So that's how you write, convert from the logarithmic to the exponent. The next question is the number 3. I asked you to write in logarithmic form. So now we go backward. Here we go forward to exponent. Now we go backward to the logarithmic. So let me erase this. So let's do part 3 here. Part 3, we go backward. So given our form in the exponent form, and we asked to write in logarithmic form. So how do we do that? So for A, we know the base is 7. So we will say log of 7 because that is the base. And you write the number 7 below a little bit, right? Not the same level with the log number 7. And of 343 equal this power equal 3. So that's how you convert it. For B, we'll write log of base 6 and to this number, right, of this number. And of course, the answer for log of this number will be equal -2. So the next one, we use a letter. In general, you can write log of the base is A. So you write the base A of this number C will be equal, the exponent here is B. So if they give you the letter, this is how you write it. Just remember the base, right? This is the base, and this is the number, and the exponent is the evaluation of the log number. So let's do the last one, D. So the base is 8. So we write log of base 8 and of the number 4, and the answer will be equal to 2/3. And it's true because what? Because A to the power A to the third root, right? Third root, this is the third root, is a rational number power, but we can convert into the root. Third root, and then you power 2 will be equal this number 4. So you take the third root of 8, which is 2. 2 to power 2 equal 4. So that's how you answer the D. So what about the E? The E will be log of the base is 9 and the number is 1 over 9 will be equal the power here minus 1. And it's true because what? You know that if you have a 1 over 9 and you power minus 1, if you have a number 9 and you power minus 1, you can make it become inverse fraction because 9 over 1 will become 1 over 9. And then you convert this power minus become positive 1. But positive 1 power you don't have to write, and that equals 1 over 9. So that's the idea of how we can convert between logarithmic function to exponent and from exponent to logarithmic. This practice also help you to understand what the number of the logarithmic means to you. So let me give you a couple more of practice and see how we can do this. So let's say the question asks you to express in logarithmic form again. So let's say you have 50. So how do you express? You say log of the base is 102 of the number 1 and equal the power here 0. So let's say if you have, we will go backward this time. Let's say you have a square root of 3 and they ask you to express in exponent form. Then you know the base is third root, right? And the power is 2 equal 3. So that's the idea. Let's say if now this question asks you to solve for x, which is we have to evaluate it. So let's say you have log of 4 of 256 equal x, and they want you to evaluate that without the calculator. So you know that you can turn in the x here have to be equal 4 to power x equal 256. So let's find out what is the power to make 4 to power x equal 256. 4 to power 4 to power 4 equal to 56, right? So it means this x have to be equal 4 to power 4 because 4 to power 4 equal to 56. So let's do another evaluation. Let's say we want you to solve for x, log of x, this time the x is the base, 32 equal 5 over 2. So how do we know what kind of base to give us? So remember, this is the power, right? So we know that if you have a power 2, if you have a base 2 to power 5, it will give you this number 32. And therefore, our base should be but we have a power of 5 over 2, not power 5. So it means that okay, the answer here is 5 over 2. Okay, so we have the what kind of, actually it should be like this. Okay, let me erase the top so that I have more room when we answer this question. Okay, so we know that we have some kind of number of x here. That's the base, right? 2 to the power of 5 over 2. And that have to be equal 32. So usually the 2 here represent the root and the 5 represent the power. So we want to take the square root of number 2, right? And then with power 5, it will be as 32. So our x will have to be equal square root 2. That will be the answer for this question. So now we know our x equals square root 2. Okay, let's show you another one. And still we want to solve for x, right? So let's say we have log of 1/2 of 16 equal x. So what our x here? This time our base will be 1/2 and our power will be x, and that will be equal 16. So what does that tell us? It means we have to have a -4 here, because when we have a -4, then we can bring this up and change this become +4, which is equal 16. And therefore our x is this power. So the answer here, x equal -4. That's how it looked like. This is our answer for that question. Okay, so let's do another one more. Let's say if you have log of 1,000. So let's count how many zeros we have. This is 1 million, right? 1, 2, 3, 4, 5, 6, 0. So we know the base will be 10. And the question asks for evaluation. So we know that our evaluation will be log of this number will be 6. If you count number of 0, 1, 2, 3, 4, 5, 6, which is 10 to the power 6 equal 1 million. So that's the idea. So we know the evaluation of this log will be equal 6, because the evaluation of log is the power here. Okay, so one more point I want to mention in this video, and I will end this video here. We will talk about the domain and range for the log. So let's say if you have y equal log of 3x minus 2. How do we find the domain for this? The domain is the set of x, right? Such that x minus 2, the whole bracket here, have to be bigger than 0. Remember, we key in negative number, we got error on our calculator. So this number, this whole expression here, have to be bigger than 0. And you saw the normal equation, we move this over. So x will have to be bigger than 2. And that is the domain. So we can write it like this. Say domain is a set of x such that x bigger than 2. So 2 less than x less than positive infinity. You can write like that. And that's the domain of this function. So x have to be bigger than 2, 2 less than x less than infinity. Now what about the range? For any log number, right, the exponential function go this way, but the log function is always go this way, right? Because it invert over the mirror line. So what is the range of this log? It on the way from negative infinity, and remember this one keep going, expanding, right? So therefore the range will be from negative infinity to positive infinity for the range of our log. Unless sometime we have a transformation, then it might be a little bit different if there is a transformation involved in. But the basic log is always have the range of from negative infinity this way, follow along the y-axis is a vertical asymptote, right? So from negative infinity, remember the range is the y value, right? So we look at the y value from negative infinity on, we go up this way, so to positive infinity. So that's the idea. So let's evaluate one more domain of the log. Let's say if you have a log of x here, and let's say x plus 7. So how do you find domain? Again, you will say domain here is x plus 7 have to be bigger than 0, right? This bracket here. And therefore, x have to be x have to be bigger than minus 7, which is the answer. But x have to be bigger than minus 7. And this x here, the base here, have to be different from 1. That's another condition. When you have a base here, remember the exponent, again, the exponent will have any base different from number 1, right? Because 1 to any power is just the same like 1. So therefore, the log similar x here have to be different from 1, and x have to be bigger than minus 7 in this case. And so you will state the domain is a set of x such that x will have to be bigger than minus 7 and x different from 1. So that's how you state that. And let's say you have another, let's say you have another domain of log of 3, and you have 3 minus 2x. So how do you state the domain? Again, you will say this bracket, domain is 3 minus 2x have to be bigger than 0. So minus 2x have to be bigger, move this over minus 3. But this time, because we have a negative x, so we cannot accept the negative x when we solve, but let's finish solving first. So let's say divide by 2 both sides. So negative x have to be bigger than minus 3 over 2, right? Which is 1.5. But we want to switch this, right? We cannot answer for negative x. So we say, therefore, positive x, when we switch it, we switch this one, this side, and this on 3 of them at the same time. Will be less than 3 over 2. which is x have to be less than 1.5. And that is how you state this domain. So in other words, if you want to put in more obvious explanation, you will say domain of this, right? Will be a set of x such that x less than 1.5, so it will be negative infinity less than x less than 1.5. And that's how you state the domain for this. And again, the range is just a set of y such that in this case, we know that there is the reflection over the x. So normal log will go like this, but there's a reflection over the y axis. So it goes this way and 1.5. So this is 1.5. This is the vertical asymptote. And the x go this way, something like that. So still, the range is negative infinity to positive infinity, similar. So that's the lesson today for our lesson about logarithmic function. I hope you will enjoy and you'll be able to follow me. Give me a comment to say if I go so fast or I go so slow, so I know the next time I will do better. Thank you for watching, everyone, and stay tuned for our next video. Our next video, I would like to talk about the properties of logarithmic. And you will have a lot of fun for doing this function because this is new and a lot of things involved. Sometimes apply the laws of log and, operations, something like that. So stay tuned for that. And I hope you enjoy my video today. See you in the next video. Bye for now.